In this tutorial, we will investigate the concept of escape velocity, the velocity at which, for example, a rocket would need to blast off to escape the gravitational force of a planet or a moon. So for our example, we will calculate the escape velocity from the Earth. You've been learning about the missions to the moon, and this was the first step for the rockets to escape the gravitational force of the Earth. So we will use the escape velocity equation that's in your textbook, and that escape velocity is given by the square root of 2 times the gravitational constant, capital G, multiplied by the mass of the object that needs to be escaped, and then the radius of the distance from the center of the object. So for our particular example, the gravitational constant is 6.67 times 10 to the minus 11, as always, and this is in units of meters squared per kilogram per second squared. And the mass in this case is the mass of the Earth, since that's what we would like to escape. And that's given by approximately 6.0 times 10 to the 24 kilograms. And the radius, since our rocket will be on the Earth's surface, the radius will be the radius of the Earth. And that's given by 6.4 times 10 to the 6 meters. And again, you always want to check that the units make sense. And if we have in the gravitational constant units of kilograms, then we know that the mass of the Earth also needs to be expressed in kilograms. And the radius needs to be expressed in meters to match the, again, the gravitational constant, capital G. So next we'll substitute the values into our square root here. So we need to multiply 2 times this 6.67 times 10 to the minus 11, and multiply that by 6 times 10 to the 24 in the numerator, and then in the denominator we have the radius of the Earth, 6.4 times 10 to the 6th. And so putting all those values into the calculator gives the square root of 1.25 times 10 to the 8. And then you can check this number, that it gives 1.1 times 10 to the 4, and this is in units of meters per second. Now that's a correct value, but it's more common to express the escape velocity from the Earth in kilometers instead of meters. So let's go ahead and do a unit conversion here, where in any given kilometer there's 10 to the 3 meters, so we'll use that conversion factor to then go ahead and cancel off the units of meters and be left with kilometers. And that gives the more familiar result that you may have read in science articles, that the escape velocity of the Earth is approximately 11 kilometers per second. So that's our final value that we need to have the rocket reach as the first step in some of these lunar missions that you've been reading about.